So amidst all the accounts I have somehow managed to be with you, and it is my privilege to be with you. So with this, I am sharing my PowerPoint presentation to you.
क्या प्रॉब्लम क्या है वो वाला अपना निकाल दो ना वो वाले उसका ये बताओ
I hope that it is visible. Okay. So if there is any problem, please send a screen message or your voice message, please. So in this very session, we are going to discuss about the essence of statistics, inferential statistics, which is running functioning along parametric test. As you all might have learned about non-parametric test and other aspects of the statistics, now it is very imperative to learn about why it is to be used, why we use parametric test and under what circumstances. Because there are so many data sets for a researcher, and to analyze those data sets and reach to certain conclusion, to certain inference, it becomes very important to first of all find out, recognize the nature of the data. So whether we are going to use parametric test or non-parametric test, it depends on the intellect of the researcher, whether how much efficient he or she is in determining and recognizing the nature of the data. Right? Whether it is, you might have studied about different types of a scale, nominal scale, ordinal scale, ratio scale, and all. So on what scale the data has been presented, data has been collected, and what is the distribution of the data, whether it is normally distributed or skewed data, abnormally distributed, biased or unbiased. So all these specific terminology are taken into consideration while conducting certain statistical tests. Okay. So the different types of data are being collected by the different discipline researchers, whether they are the researchers, you are the researchers from medical field, you are the researcher from social field, you are the researcher from commerce background, business background, or whatever it may be. The nature of data differs from discipline to discipline, objective to objective, right? So, first of all, we need to know, we need to understand the basics that why in statistics such kind of measurements becomes essential. We are interested to measure the properties of the data first of all. Right? What are the basic properties of the data? And then when it is determined the basic properties of the data, nature of the data, then it becomes very easy for the researcher what kind of statistical tools to be used. Right? So the measurement of the data is conducted for the purpose of finding out the accuracy. Accuracy regarding what? Accuracy regarding how well does our model match the data to predict the hidden value that the researcher is not so far confirmed or evident about. So they have certain hypotheses, they have certain thoughts. We all have certain intuition regarding certain data set that we collect, that this may be the outcome, that may be the outcome. But to validate and to reach the certain conclusion, we have to apply certain statistical tool and validate them. In mathematics, it is 2 plus 2, 4. It is obvious. But when we talk of statistics, if it is 2 plus 2, 4, how it is and why it is, that is interpreted. So most of the time, many of the time when we collect data, while collecting data, we get a sense of definition, we get a sense of solution that this will be the answer about this very population. जिस population से हम data उठाते हैं, उस population से data उठाते वक्त, उसको collect करते वक्त की बहुत सारी चीजें हमें समझ में आ जाती हैं. Still we need to validate that. still lead to certain conclusion. It is only because of that we have certain hypothesis. क्योंकि हमें पता है कि ज्यादातर चांसेस हैं कि इसका ये आउटकम होना है, इसका ये रिजल्ट आना है. If certain things have been applied to certain community, that will be the result. So we all know that if a boy is given tuition of mathematics, there is huge probability that his marks will be increased, right? But to validate that, we need to take help of certain statistics, whether it has a certain impact or not. Before and after, that difference is critically analyzed, that difference is recognized with the help of statistical tools. So the accuracy takes that. This measurement takes whether the data set is enough, abundant for running certain statistics, or whether, on the other hand, vice versa, whether that statistical tool is fitting for that very data set or not. Right. So here we can see, you might have come across all these variance and biasness and all. So this, in the right side, there are red bubbles you can see on the scatter plot, and a square in blue color shows that it is sample size. Although we are willing to, हम चाहते हैं कि पूरी पॉपुलेशन के बारे में जानकारी, बट ये पॉसिबल नहीं होता है कि हम पूरे पॉपुलेशन का इंफॉर्मेशन लेकर के और उस वाइड डेटा पे एनालिसिस करें, because it will be costly, it will be time taking, and sometimes it will be also vague in giving result, right? So to put to the concise manner, to get a result, exact result about to get a proposition about the entire population, we draw certain sample. So after drawing that certain sample, we need to look into the fact that whether the data are normally distributed. Okay. Whether the data are normally distributed or not, that is of prime importance. It is because data is normally distributed, perfectly normal distribution, and all the median and mode value falls into the equal zone, then this brain shape icon you will be finding after analyzing the nature of the data. Right. So when data is normal in nature, then certain tools like t-test, ANOVA test, chi-square test, Pearson correlation coefficient can be very useful in getting most accurate inferences, most accurate answers to the data analysis, right? So here we can see that these are the three forms: normal curve, positively skewed curve, and negatively skewed curve has been given. And if our data set is normal in nature, right, then only we are going to use parametric tests. And parametric tests are believed to be the most important and most accurate tests. In fact, this does not mean that the non-parametric are useless or not important or not getting the exact result. The non-parametric test also gives 95% of the accuracy as compared to the parametric test. So that 5% makes difference between parametric and non-parametric test. And if the nature of the data is positively skewed or negatively skewed, and under such circumstances, ऐसी स्थिति में जब आपका डेटा जो है नेगेटिवली स्क्यूड है या पॉजिटिवली स्क्यूड है, मतलब बहुत ज्यादा एब्नॉर्मल डिस्ट्रीब्यूशन ऑफ डेटा अगर आपको है मिल रहा है, इन दैट केस क्या होगा, ये जो बेस शिफ्ट आइटम है दैट विल शिफ्ट आइदर लेफ्ट साइड और राइट साइड, एंड इफ इट इज शिफ्टिंग दिस राइट साइड और लेफ्ट साइड, then we should simply conclude that we are not in position to perfectly apply the parametric test, right? Therefore, we take help of the non-parametric test. So once we are done with the normal distribution of the data, we have to make certain hypotheses about the entire population, okay, and hypothesis about the sample. So when we talk of hypothesis about the entire population, it is represented here by HA, and the population samples hypothesis has been represented by HG. This means that we want to prove a hypothesis HA. हम चाहते हैं कि हम पूरे पॉपुलेशन के बारे में कोई धारणा बना पाए, पूरे पॉपुलेशन के बारे में हम बात कर पाए, लेकिन ऑन बेसिस ऑफ व्हाट? पूरे पॉपुलेशन के बारे में धारणा बनाने के लिए हम क्या करते हैं, छोटा सा सैंपल उठाते हैं पॉपुलेशन में से सैंपल, और फिर उस पॉपुलेशन के बारे में टेस्ट स्टैटिस्टिक्स जो निर्धारित करते हैं, वो जो बिग पॉपुलेशन साइज है उसको वैलिडेट करते हैं। सो these are the questions in hypothesis testing. I want to stick to this as we will be going to the parametric test. Okay. So now from here we are starting. Actually, the statistical tests are intended to decide whether a hypothesis about certain population, about the data set that we have collected, are to be rejected or accepted. Okay. We make certain assumptions about that data with the objective that we collect. So that the statistical tests are parametric and non-parametric. When we talk about parametric test, it is the statistical tests that make certain things एक assumption बना लेता है कि वो जो एक जितना छोटा से छोटा आप सैंपल उठाएंगे, जितना छोटा से छोटा सैंपल होगा up to 30 size, right? It has been interpreted that up to 30 size of data set is believed to be accurate for the use of parametric test. If it is beyond that, then the parametric test will not be applicable or will not be getting you the perfect result as desired by you. Why it is so? It is so because suppose that we are having fever or we are having headache. So up to certain extent, our headache can be controlled and tackled with the help of Disprin. But if Disprin is not very much effective enough to tackle with that very disease or that very uncomfort zone that we are having through headache, then we used to take some higher powered medicine, that suppose that Nicosolide or something else. So it is just like that. It is not that on each and every data set we can apply parametric or non-parametric with our choice, thinking all that I am comfortable in using non-parametric test or I am comfortable in using parametric test. So when we are using parametric test, we need to take care of all these things, that it is used for the quantitative data, and specifically when the data has been collected on ratio scale. Used for the continuous variables. Third one is it is applied on approximate interval and ratio scales of the measurement, and data should follow the normal distribution. It is the most significant consideration while using parametric test. Now, when we talk about the parametric test, there is t-test for one sample. When the one sample has been drawn from the population, किसी population में से जब हम एक sample उठा करके उसके inference तक पहुंचना चाहते हैं, और given all that कि ये सारे application जो assumptions हैं हमारे, ये सारे assumptions वो data से match करता है कि वो continuous variable की हो, वो quantitative nature में हो, qualitative nature का data नहीं हो, right? While collecting data, we know that what is qualitative nature of data and quantitative nature of data. So the data should be quantitative in nature, continuous data variables should be there, interval and ratio scale must be there, and data should be following normal distribution. All those assumptions are met while drawing a sample from a population, large population, and the sample size should not exceed 30, right? And one sample t-test and say two sample t-test can be utilized. The two sample t-test is further divided into paired t-test and unpaired two sample t-test. Paired t-test क्या है? टेस्ट क्या है कि जब एक ही सैंपल पे हम दो बार चीजें अप्लाई करते हैं. Suppose that before giving certain medication, what was the result? What was the impact of those five subjects? And after applying those medicines, what are the impact of those 5 subjects? So that will be compared. Mean जो है हम दोनों ही sample का before applying the medicine and after applying the medicine, the mean value of both the samples are statistically different, significantly different or not different. So that is a study method. Under this, the different samples are taken into consideration. Two different samples will be taken into consideration, but but both the samples will be drawn from same population, but that they cannot be paired. They cannot be paired because they are the different samples. So these are the basics, and then there comes ANOVA, analysis of variance. When sample size increases, then 30, then F test is used. So one way ANOVA is there, two way ANOVA is there, one way ANOVA is there. That means that when we try to analyze, when we try to find out impact of one factor over the dependent variable. Suppose that use of fertilizers, we are trying to assess whether the use of fertilizers are making enough changes in the productivity of certain crops. Okay, and when we talk of more than one variable, suppose that we are having fertilizers, we are taking into consideration the irrigation facility, we are taking into consideration the pesticides, right? So if there are so many factors given there, and we are trying to assess or find out the impact of those factors on the productivity, then we are going to use analysis of variance. What kind of variance are being caused by the use of those factors, use of those independent factors, right? And then there comes the Pearson's population coefficient and Z test. So these are the tests. So first of all, we need to know the very basic test, that is called a student t-test. The student t-test was developed by W.S. Gossett. Why it is called a student t-test? It is because the firm in which W.S. Gossett was working did not allow any kind of research in public domain by their employees. So the Gossett was thinking to develop this, to establish this epistemology of t-test, and therefore he wrote a paper in the name of a student, just a student. In the pen name of a student, he wrote a paper where he described and initiated this t-test, and later on which became popular in the name of student's t-test. So a t-test compares the difference between two means of different groups to determine whether the difference is significant or not, right? दो ग्रुप को लेते हैं, उन दोनों ही ग्रुप के मीन को देखते हैं, और वो दोनों ही ग्रुप जो सैंपल का हमने लिया है वो एक ही पॉपुलेशन से होगा। यह ध्यान रखना है कि दोनों ही सैंपल को हम एक ही पॉपुलेशन से ले रहे हैं, और आप में यह वेरीफाई कर रहे हैं कि उन दोनों ही सैंपल के बीच में मीन वैल्यू जो है वो वो डिफरेंट है या नहीं, वो डिफरेंस जो है वो सिग्निफिकेंट है या नहीं, राइट? So for that, one sample t-test when we are conducting, we took into consideration various assumptions like population is normally distributed, sample is drawn from the population, and it should be random. It should be random sample. Because when sample is not random, there is high probability of getting it biased. And if it is a bias, then it will not be normally considered as the simple the rational distribution of the data. So we should know the population mean as well. So there will be a population mean, right? Then we will be finding the sample mean as well. The sample size should be less than 30. Population should be normally distributed, and given the condition that population standard deviation is no norm. The standard deviation to the population का वो हमें नहीं पता है, right? And in one sample t-test, we know the population mean, right? ये सारी चीजें जब हमें मिल जाती है, then we used to compare the sample mean and the population. Population mean हमारे पास है, sample mean we are going to calculate. Our standard deviation is even, and now we have put it under certain formula, right? So let us assume that this is the data set of n number of data is given. Right? N is the population size, and then sample size has been drawn from them, from normally distributed population, and this is represented by mean, mu, and variance, standard deviation, that is variance square, right? So the test statistics formula says that P is equal to this This is called the sample mean, and this is called the population mean, and upon variance divided by under root n. N is representing the sample size, right? So here we can see it that P is equal to sample mean minus population mean. Here you can see in this formula that x bar is representing sample mean, mu is representing population mean, and then there comes s upon under root m, that is extended there, right? So this is s square, variance is being calculated by sum of this, the total population minus the population mean on the whole square upon the sample size minus 1, right? So we get all these things, and now when we get the result, try to compare factor based on the level of significance that we considered at the 95% level of confidence or 1% level of 99% level of confidence, right? So if it will be 5%, that means that our p value with which we have to alpha value with which we have to compare our p value will be 0.05. 0.05. So if the calculated value is less than 0.05, if the calculated value of this very formula is less than 0.05, then what will happen? We will have to accept the null hypothesis that says that there is no any significant or statistical significant difference between mean of the two groups, right? So if absolute value of P of it is greater than the capital value, then we reject the null hypothesis. As we can see, if that value is greater than 0.05, then we are going to reject the null hypothesis, and we will be accepting the alternate hypothesis, which may be interpreted as there is significant difference between mean of the two groups, right? So if means here means the student test, we can simply say that the calculated sample value, sample mean, is not equal to the sample, not equal to the mean of the entire population. I mean the mean of the population and mean of the sample population that you have taken is quite different. So this becomes it. When we talk of the two sample t-test, it is used when two independent random samples we have derived from the normal population. एक ही population में से दो सैंपल आपने ले लिया है। इसके पहले क्या था कि एक सैंपल आपने लिया है और उस सैंपल के मीन को पॉपुलेशन के मीन से कंपेयर करते हैं कि वो दोनों मीन बराबर है या नहीं, वो दोनों मीन स्टैटिस्टिकली डिफरेंट है, डिफरेंस है उनके बीच में या नहीं। अब यहाँ पे क्या कर रहे हैं, यहाँ पे we are drawing two different samples from that population, okay? And then we are trying to interpret that the sample 1 and sample 2 are having equal mean. Earlier it was we compared the mean of the sample size and the mean of the population. Now in two sample meters we are comparing the mean of both the sample size that we have drawn from the same population, right? So here the populations are distributed normally. Again, we need to take into consideration these assumptions, because when assumption will change, your text will change. Assumption जैसे ही बदलेगा, आपको अपना जो मशीन भी इस्तेमाल करना है, जो इंस्ट्रूमेंट इस्तेमाल करना है, वो उसका बदल जाएगा, ठीक है? So the samples are drawn independently and at random from the same population. The standard deviation in population are same and no more. Okay? Size of the sample is small, that is certainly less than 30. Here the formula becomes different. See, if we draw two independent samples, that is X and Y, right? We have drawn samples from and given name of Xi as sample 1 and Yj as sample 2, right? And now we are going to compare along the test statistics whether the mean of both these samples, this sample and this sample is equal or not. If it is equal, it means that there is no any significant difference between the mean of these two values, and same will be our null hypothesis. See, the null hypothesis says that there is no any difference. No any difference means the mean of sample 1 and mean of sample 2 is equal. So that we have assumed. Now the formula is given here. T is equal to x bar minus y bar upon s into under root 1 upon n1 plus 1 upon n2. N1 is this sample size of sample 1 and sample size of sample 2. Here suppose that I have taken an example. अभी एक एग्जांपल लेते हैं समझने के लिए, क्योंकि it is very technical and when not two-way communication it becomes very difficult to make you understand, and it must be going above your mind something, right? So to understand well, we have taken an example. In this example, it says that a group of 5 patients, 5 लोग हैं, 5 बच्चे हैं between the age of 30 to 50, treated with weight gainer. इनको weight gainer A दिया गया, ठीक है? Had weight of this, और फिर जो sample size यूजुअल लिए हम, वो weight gainer B वाला जो ग्रुप बना दिया हमने यहाँ पे, और ये sample size में differ. It can be said that the medicine A and medicine B have similar impact on weight of the T patients of sample size A and sample size B taken from the same population. एक ही population में से ये sample उठाया, एक ही population में से ये sample उठाया, sample size may be differing, right? That we are not sticking to having the similar sample size. Otherwise, the similar sample size had been taken, we have taken, then it would be having probability of falling under the category of paired t-test. Paired t-test, right? So here we are having the different sample size, two sample size, and from the same population. Now we are trying to find out there is no any significant difference between the mean of the two samples. एक sample ये लिया, एक sample ये लिया, और अब हम कहें null hypothesis कह रहा है कि there is no any significant difference between the mean of the two samples. Or there is no any significant difference between the impact of medicine on sample size A and medicine on sample size B from the same population, right? So here we can see the sample size. Now, this is the snapshot that we can simply understand through. That sample 1 is given here, right? Sample X is given here, sample Y is given. Sample X is sample A, sample Y is sample B. So what we are going to do? We are going to apply this very formula. Right? How we are going to apply? We have to find out this X bar, we have to find out this Y bar, and then we have to calculate this standard deviation variance, right? So to find out X bar, what is the formula? It is A assumed B plus summation of B upon N1. N1 why we are taking? N1 we are taking because it is the sample size, sample 1. Okay, it is the sample 2, right? So it will be considered as N2. So here we can see this partition, and in this partition we find that X bar can be determined with the help of assumed B plus summation of B upon N1 is equal to 25. Why 25 is there? It is because here we have assumed 25 as assumed B, right? And D is equal to, जो यहाँ पे D है, summation B है, ये D निकालने के लिए हमने क्या किया? X यानी ये value minus assumed B. So 24 minus assumed B हमने क्या ले लिया था? 25 ले लिया था. तो 24 minus this A, and assumed mean is 25. So 24 minus 25, this X minus 25. So here it is giving result minus 2. Likewise, we get all the figures. 27 minus 25, 26 minus 25 this value, 21 minus 25 we get this value, 25 minus 25 we get this 0, right? So now
summation of P is being said. Here in this formula it is said summation of P. So we will add them all. What we will do? We will add them all. हमने सबको जोड़ दिया और फिर हमको जोड़ करके क्या मिला माइनस ये मिल गया। अब कह रहा है कि यहाँ पे कह रहा है कि स्क्वायर ऑफ दिस समेशन ऑफ राइट। सो वी विल गेट a square of this minus 1 into minus 1 1 likewise we get this value minus 4 into minus 4 we get 60 okay by the mathematical laws we get verifying the value of minus right so after adding all summation of p square see summation of p square we have to find out in this time similarly we get the same value similar calculation for sample size sample p okay and we put all those values here. We put all those values here. We get this value and then x minus x bar is determined with the help of this. So we are getting one value 21.2. This 21.2 is the value for sample size sample A, right? And similarly we are getting another value 108 by applying same formula by applying same mechanism for sample B. So we have got the two figures. We have got figure 21.2 and we have got figure 108. Now the question is that we have this. What it is called? We need to remember these things. What it is called? It is called S input under root 1 upon n1, 1 upon sample 1, sample size 1 plus 1 upon sample size 2, right? So see, we are having similar. If this S was outside, S square was outside because only this. Then we have brought this S inside the square root. Then it has become the square of that S, right? So here S square is being variance is being calculated with the help of this formula 1 upon sample size 1 plus sample size 2 minus 2, right? And we get the same value, right? We get this value by calculating all these things, by putting all this value, right? You can see it has written 21.2 plus 108 upon 9, right? So 21 plus 2, 21.2 is the result of sample A and 108 is the result of sample B. So this is being added upon this sample size 5 plus sample size 6. So 5 plus 6 is equal to 11 minus 2. So therefore this is getting the result 14.36, right? So test statistics, when we talk of the test statistics, we have considered the same formula and we have put all those values in this formula and we get this tabulated value. We get this tabulated value T at degree of freedom 9. This is the degree of freedom 9. So we are at 5% degree of freedom. Applying to take test, we are getting this. Since the calculated t-test value is less than calculated t-test value है minus 1.9, calculated t-test value है minus 1.92 और इससे जो हमको वैल्यू को कंपेयर करना है वो tabulated value से कंपेयर करना है। The tabulated value is 2.262. So if it is less than that, we have discussed that here. If it is less than that, then what we will do? We will be accepting the null hypothesis. Since we say that the null hypothesis will be accepted at 5% level of significance, and we conclude that the samples coming through the same population, which are normally distributed, are having similar weight. Okay, so this way we calculate that, and then there comes the when we are using the variable, what it is being said, it is the same substance. इन वही पांच लोगों को उठाते हैं और उसके ऊपर जो है कह रहा है कि determine the significance of a difference in blood pressure before and after the administration of experimental research substance. दवा देने से पहले पांच लोगों को